We're going to take a look at the symmetry of some graphs. Some graphs have symmetry, others don't, and there's different types of symmetries as well. For this lecture, we're really only going to take a look at two different types of symmetries. We're going to take a look at something called even symmetry and odd symmetry. Now, even symmetry is probably the easiest of the two for us to envision. This just means a graph is symmetric about the y-axis, and odd is if something is symmetric about the origin. All right, so those are the two types of symmetries we're going to look at. Let's see how we could tell mathematically if something is an even function or an odd function. Let's take a look at our old friend, the parabola here. Our parabola, we would say, has even symmetry, which means it's symmetric here about our y-axis. Now, what do we mean by symmetric? Basically, across the y-axis, it's a mirror image of itself. So, or another way to think about it, if you could take this board, fold it along the y-axis, this side would lay directly on that side. So if we call this function, let's say, is f of x, what test could we do mathematically to tell if a function is an even function? Well, the idea here is if we go over some value, let's randomly call it x, and go up here, then that y value would be f of x, right? The function with x plugged into it. However, if we go the same distance this way, right, so that'd be the opposite of x, and we come up here and we put a dot there, this y value would be f of negative x. So the idea, if we go some distance this way, we get a y value. If we go the same distance this way, we get another y value. Well, for this thing to be symmetric about the y-axis, those two y values have to be the same, right? Because this y value has to be the same as that one when we fold it over. So the test for an even function is we want to see, does f of x equal f of negative x? My blue marker's dying. Okay, so what about for odd? Well, odd's a little bit more difficult to see, at least visually for a lot of people. Symmetric about the origin, you're like, can you be symmetric about a point? Well, think about our old friend x cubed. This is one that we can all kind of see. I'm just going to call it f of x though. To be symmetric about the origin, what we actually have to do, instead of folding once, we actually have to fold twice. So imagine, so there's our origin, we're going to go across it. Imagine if we fold this along this way along the y-axis. We fold it this way, this side would actually kind of come over here and look something like that. Then if we were to take this and fold it on the x-axis, notice the dotted line should now lay right on top of this piece if it really is symmetric about the origin, or if it really is an odd function. So for this time, we got to kind of picture two folds. But the idea of how we're going to get to the mathematical definition is kind of the same. Think about it here. If we go over some distance x, we get a point, and that would be f at x. If we go over the same distance this way, that would be negative x. We'd have another y value down here. This would be f of negative x. So I'm just going to put some numbers in here real quick. So if we plugged in 4, let's say we got out 8. That's not for this, but if we plugged in 4, we got out 8. Then over here, if we plugged in negative 4, we'd have to get negative 8, which means whatever this y value is, this has to be the opposite of it, right? If this is 10, that would have to be negative 10. If this is 12, that'd have to be negative 12. So for this to be true, and my blue marker's dying, I'm going to go and try it again. F of negative x, f of negative x, that's this y value, would have to be equal to the opposite of that y value. Would have to be equal to negative f of x. Okay, so there's our two tests to tell if a function is either even or if a function is odd. Now, if a function's not even or odd, we just say that it's neither. It doesn't have to be even or odd. It could be one or the other or not at all. So let's take a look at a couple of functions and see if we can tell if the functions are odd or even. So determine if the function is odd, even, or neither. Okay, so let's just start out with some function. Let's say f of x is equal to x cubed plus x. All right, let's tell if this function is odd or even. Well, here's the good news. Here's the way we're always going to do this. Notice our first test starts out with the function, so we already have that piece. We need f of negative x. Now the good news is we actually need that for our next test anyway. So the first thing I'm going to do is take this expression, and everywhere there's an x, I'm going to replace it with negative x. So this will be negative x cubed plus negative x. And then we need to simplify. Now remember, if you have a negative to an odd power, that result is still negative. And of course, that's just negative x. Okay, now what you need to do here is we need to compare these two. Does our original function equal the function when we plugged in negative x? So the question is, do these two equal? And they don't equal, so they're not. This function is not even. Okay, now we need f of negative x for our next test. So the only thing I need for my next test is negative f of x. That just says take the f of x, whatever it is, and put a negative in front of the whole thing. So there you go, I just put a negative in front of f of x. Then we distribute, and I get negative x cubed minus x. Now we got to compare these two. So f of negative x is this, and that's negative f of x. So f of negative x is this, negative f of x is this. Notice they're the same. So these equal. So f of x is odd. Okay, there you go. That's all you have to do. Now, if it had been even to start with, you don't need to check to see if it's odd. There's very few functions that are both even and odd. They end up being kind of very strange functions. Like the x-axis is both even and odd. The origin, the origin is both even and odd. But most of the time, if you find out that a function is even, you do not need to check to see if it's odd. All right, so let me give you guys one to try right here. So here's the one I want you to check. I want you to do f of x is equal to x squared plus x minus 2. All right, pause the video, run it through the test, and tell me if that function is even, if it's odd, or of course if it fails both, it will be neither. All right, if you're back, let's see how you did. So for the first test, the test to see that it is even, I need to figure out what f of negative x is. That says go into our function. Everywhere there's an x, replace it with a negative x. Now here I know if I take a negative and raise it to an even power, the negative turns into a positive, so that's just x squared minus x minus 2. Then we compare these first two. Are those two the same? In this case, they're not. So this is not even. All right, so we already have f of negative x. Now we got to compare that to negative f of x. So take the entire function f of x, put it in parentheses with a negative in front. So that's negative x squared minus x plus 2. Now we want to compare those two. Are those two the same? If those two are not the same, then this is not odd. So if it's not odd and it's not even, this function is neither. Okay, being able to tell symmetry of a function is kind of nice, especially when you're graphing it, because you know what the picture is going to have to look like. Especially kind of our even symmetry we use a lot, of course, when we're graphing parabolas. So make sure that you can tell whether a function is even or odd. And of course, if it's not either one of those, the function's neither.